object storage is all about us lumping huge amounts of data, potentially vast amounts of data, in potentially disparate places all over the place, and the ability to scale really, really easily. But it's not fast. You know, it can be. We can optimize it. We can do things to make it quicker. But it's not like the hard drive spinning inside our PC. That's fast storage. You know, that is quick, simple. In IT terms, we're worrying about SANs and storage platforms and bits and pieces where we want high-speed disks that run virtual machines where we're paging memory onto disk and things like that. And that's got to be quick and fast and structured, like your filing cabinet example, right? We need to know where to go to get stuff. Object storage is all about scale, volume, and it doesn't necessarily always need to be fast. So great for backups, great for kind of big data depositories, data lakes, artificial intelligence, things like that. File level storage, PCs, servers, USB keys, flash storage, things like that. So it's fair to say that object storage can also have all these mediums. It can have spinning disks and flash storage and all these kind of bits and pieces. But it's the way we engage with it that's totally different. We're driven by APIs and calls and metadata. And we don't care really about how structured that data is and whether it's a particular PDF file or Word document. We don't care about files. We care about random blobs of data with ones and zeros in, with a tiny little file, metadata, attached to it saying, this is part 1 of 9. Go and find the other 8.
And that's where this whole concept of unstructured data versus structured data comes in, I'm guessing.
Yeah.
Cool. All right.
So what does it do then? So what you're saying is due to metadata, because I only think of metadata when I look at cameras, and I remember seeing my first digital camera and metadata was part of it and how that was stored. And I guess in this way, what you're saying is it breaks up these pieces of data, stores it on separate disks somewhere.
Yeah, can do.
And then uses that metadata to synchronize it up.
So you've got choices there. Sometimes it's simpler and quicker to transfer certain block sizes of data rather than massive blocks or lots and lots of tiny blocks. Sometimes it's easier to break a really big file up into pieces and then stream those pieces all at the same time, pull them all out of the system at the same time. We get much more, much faster network.
More like packet sizes.
Exactly. But it's a balancing act. So depending on which object storage provider you use, you can have lots of choices about the packet size, what the actual data is that you're pulling out. And this touches slightly on some of the things that we do. Like if we're pulling out one big file, let's say we're watching a video and we want to download that video. We can pull one big file that might be 4 gig in size, and I'm going to slowly download each bit at a time. Buffering, exactly. But I'm pulling each little bit at a time. Whereas actually, when you introduce load balancing, we could have lots of servers where we're pulling data from all of them.
Okay.